Today we're going to look at solving linear inequalities a second day. So we're going to start with the warm-up. Graph the following inequalities on a number line, and this is what we did yesterday. So for number 1, x is greater than 2. So we're going to find 2, and if it's greater than 2, we're going to use an open dot to show that it's bigger than 2, but it can't, 2 is not part of it. It can't be equal to 2. So open dot, and then we're going to color in the side of the line that shows that x is greater than 2. So all these numbers to the right-hand side of 2 are greater than 2. Let's try the next one. 3 is greater than or equal to x. 3 is greater than or equal to x. An easier way to think about this, for me at least, is to change the order of it. I'm going to start with x. And if you notice, x is less than or equal to 3. And that's a little bit easier for me to understand. So we have x is less than or equal to 3. So at 3 we're going to put a filled in circle because x can equal 3, but it's also x is less than or equal to 3. So we're going to color in the left side of the line. And all these numbers are less than 3, and it can equal 3 as well. All right, the next one, 4 is less than x, which is less than or equal to 10. All right, so if x is in the middle, I'm going to find 4. I'll put an open dot because there's no equal sign. At 10, I'll put a closed dot, and x is between them. So this right here, this picture would stand for x. 4 is less than x, which is less than or equal to 10. The next one we have 1 is less than or equal to x, which is less than 7. So start the 1, close circle because of that equal sign. Put an open dot at 7, and then we're going to color again in between them. So this stands for 1 is less than or equal to x, which is less than 7. So our learning targets today, looks like there's just one here. I can solve linear inequalities that have multiplication and division with a negative number. So let's start by completing the following table. Consider each statement below. Determine which final statements are true and which are false. So the first, if we look at all the original statements, they're the same. 4 is less than 8. That is true. Now let's go down this column here. Let's add 2 to both sides. 4 plus 2 is 6. 8 plus 2 is 10. Is this true or false? Is 6 less than 10? This is true. Let's try the next one. So again, we start with 4 is less than 8. We're going to subtract 2 from both sides. 4 minus 2 is 2. 8 minus 2 is 6. Is 2 less than 6? That is true. Okay, we're going to try the next one. Multiply each side by negative 2. Okay, so 4 times negative 2 is negative 8. 8 times negative 2 is negative 16. Is negative 8 less than negative 16? And that would be false. Negative 8 is bigger than negative 16, so this is false. Let's try the last one. Divide each side by negative 2. What's 4 divided by negative 2? That would be negative 2. What's 8 divided by negative 2? That's negative 4. Is negative 2 smaller than negative 4? And again, that is false. So it says if we multiply or divide by a negative number, we get an untrue statement. We can fix this by switching the direction of the inequality. So if we were to switch the direction of the inequality here, then both of those statements would have been true. Okay, so let's try a few with this rule where we're going to switch the direction of the inequality if we multiply or divide by a negative. So the first one, let's draw my line down here. Okay, first step, subtract 2 from each side. We get negative 2x is greater than 6. Divide each side by negative 2. So we get x is greater than negative 3. Oh, but I forgot, we have to switch the direction of the inequality. So here if we divide by a negative, we will switch the direction of the inequality. So we're switching the direction. So here is our answer. If we plug in any number here where x is less than negative 3, this will be a true statement. So let's try it. What number is smaller than negative 3? Negative 4 is, so let's try that. Is negative 2 times negative 4 plus 2, is that less than 8? So again, all I did was plug into the original statement here. Let's check and see if it's true. So negative 2 times negative 4 is 8. Is 8 plus 2, oh, but I used the wrong sign here. We want to check and see if it's greater than 8. Is 8 plus 2 greater than 8? We got 10 is greater than 8, and that works. That is true. So you can check your answers, just like when we solve equations. You can check your answers for inequalities by plugging in values and seeing if the statement's true. All right, let's try the next one. So for this first one, let me draw my line down here. All right, so first up, get rid of the divided by -3 first. So to do that, we're going to multiply each side by -3. On this side, they cancel. We get x plus 2 is less than or equal to 12. We multiplied by a -3, so I have to switch the direction of my inequality. So greater than or equal to 12. And then we'll subtract 2 from each side. And we get x is greater than or equal to 10. So if I plug in any number bigger than or equal to 10, this will be true. So let's do the same thing, but also graph our answers on a number line. So there's 4 examples, and then you guys have a worksheet to do in class. All right, so the first one here, we are going to add 4 to each side first. We get -1/2 x is less than, this is 8, -8. And now we're going to divide by -1/2, or you could multiply by -2, both would work. And since we're dividing by a negative, we're going to switch the direction of the inequality. 8 divided by -2 is the same as -16. But it's a -8 times a negative. Okay, so -8 divided by -1/2. Positive 16. So x is greater than positive 16. Let's draw a number line for that. I should have given myself more room here. Okay, so my number line will look like this. X is greater than 16, so 16, 17, 18, 19, 20. Just draw some numbers here. And then greater than 16, so here's my open circle. We're going to color in greater than 16 right here. Okay, let's try the next one. So first up, add 17 to each side. We get -1/3 x is greater than or equal to, 21? And then here, again, we can divide by this negative, but if you think about what number multiplies to -1/3 to make it 1, dividing by -1/3 is the same as multiplying by 3, because then they'll cancel. So let's multiply this by -3. And since we multiply by a negative, switch the direction of the inequality. And if we do that, we're going to get -63. So x is less than or equal to -63. Smaller than, okay, so let's start at -63, and it's less than or equal to, so here's -65. Let's go this way, so it's a closed dot, and x is less than or equal to -63. Okay, let's try 2 more. Okay, so we have 16 is greater than or equal to, and I'm going to rewrite this one. I'll do 13 minus 3x is less than or equal to 16. So notice the bigger side is facing the 16. All right, now we'll solve. So subtract 13 from each side. We're going to get -3x is less than or equal to 3. Divide each side by -3. Since we're dividing by a negative, switch the direction of the inequality. And we get x is greater than or equal to -1. Let's graph that on a number line. Here's -1, here's 0, 1, 2, 3, 4, and so on. All right, so x is greater than or equal to -1, so we can use a closed dot, and it's greater than or equal to, so we'll shade this in. Okay, last one. We're going to add 8 to each side. -z/3 is greater than or equal to 19. To get rid of the divided by 3, we're going to multiply each side by 3. So we get -z is greater than or equal to 19 times 3, 57. And how do we get rid of this negative? It's like an invisible -1. We'll divide by a -1. So we have z, and switch the direction of the inequality is less than or equal to -57. Let's graph that on the number line. I'll do it up here. So x is less than or equal to negative 57. So here's negative 57, 58, 59, 60. Here's negative 60. And it is a closed dot, right, because it's less than or equal to negative 57. So here's what our graph looks like. So today we're going to practice this. So solving inequalities is just like solving equations. The only difference is if you multiply or divide by negative, switch the direction of the inequality.